There's something about a rainbow that feels both familiar and impossible. You've seen it before, a soft curve of colors stretching across the sky. Yet each time it steals your attention like the first time you were a child looking up in wonder. It never lingers long, almost as if it's shy, appearing only when the sun and rain decide to work together. But behind that arc of beauty is a quiet, patient story. A journey that light takes without sound, without hurry, and without us noticing most of the time. Tonight, let's slow down enough to follow it. A sky after rain. When the rain stops, the air changes. You can almost smell the clean, cool scent it leaves behind. Puddles form little mirrors, and the clouds, still heavy, drift away like tired travelers. This is when the sky feels wide and alive, as if it's just taken a deep breath. Somewhere between those fading raindrops and the sun's gentle return, something begins to happen. Not in a rush, not in a storm, but in the quiet after. A kind of stage is set, even if no one calls it a performance. You've probably noticed how the light feels softer in these moments. It's not the sharp brightness of midday, nor the fading gold of sunset. It's a gentle light, as if the sun knows it's returning to a space already transformed. The clouds act like curtains parting, revealing patches of pale blue, and hidden in that light is every color you've ever seen, and colors you've never even imagined. They're there now, waiting, invisible but real. The ground beneath feels still, yet the air is alive with motion. Millions of droplets hang suspended, almost invisible until they catch the right angle. They are like tiny worlds, each holding the potential to bend light in its own way. Some are round and perfect, others stretched or trembling in the wind. It's inside these drops that the magic of a rainbow will be written. You know, what we call magic is often the meeting of the right conditions, either the right kind of light, the right kind of air, the right kind of pause in the weather. The rain has given the air something rare, a million small chances for the sun to whisper in colors. And so the sky after rain is not just a sky. It is a page the sun is about to write on. And here's the part most miss. Even now, before the first hint of a rainbow appears, it has already begun. The colors are already breaking apart, already on their way. We just haven't turned our eyes toward them yet. The first hints of hidden light. Sometimes you notice it before you realize what you're seeing. A faint blush in the air, a softness in the light, as if it's been dusted with something fine. It doesn't yet form an arc, and if you look away for too long, you might miss it entirely. This is the whisper before the song. Light is still tangled with itself, but something in the droplets has begun to loosen its grip. Colors are shifting inside, unseen, preparing to step forward. Hidden light is everywhere, even in what we think of as plain white sunlight. We grow used to thinking of it as one thing, one color, but that's only because our eyes gather it all together at once. Inside that beam are reds, oranges, yellows, greens, blues, indigos, violets, each one waiting for the right doorway to step through. And that doorway can be as small and simple as a raindrop floating in the air. When the sun sits at a certain angle, the light that strikes those drops isn't simply bouncing away, it's entering, bending, slowing down, just enough for the colors inside it to lose their perfect alignment. This separation is gentle at first, like friends drifting apart in a crowd, not because of disagreement, but because the path ahead curves differently for each one. The human eye doesn't catch this immediately. It needs a certain concentration of droplets, a certain shift in brightness before the colors grow bold enough to declare themselves. And in that waiting moment, you are standing between two worlds, one still hidden, one about to appear. There's a quiet tension in it, the kind you only notice if you're still enough to feel it. Once the first hints break free, the rest will follow quickly. The rainbow you will see is already forming in ways you cannot yet name, and soon it will reveal its full curve as if it had always been there. Droplets waiting in the air. Every raindrop left hanging in the air after a storm is a little lens, not designed by anyone, but perfect in its own way. They are round because of the balance between water's pull and the air's embrace, holding their shape just long enough to take part in something much bigger. They don't choose where they float, yet each one is in exactly the right place for light to find it. Some are close enough to your face that you could see them if you squinted. Others drift far away, too small and too distant to notice. But together they form an invisible field. Each one will take the sunlight that reaches it and bend it according to its own size, shape, and position. A single drop can hold an entire rainbow, but you will only see one fragment from where you stand. It's strange to think that the rainbow you admire is not a single thing in the sky. It's a million separate performances happening all at once, stitched together by your own eyes into one seamless arc. If you were standing somewhere else, even a few steps away, the drops giving you your rainbow would be different. There's a patience to these droplets. They drift, they tremble, they fall. Many will never be part of a rainbow at all, passing unnoticed back into the ground or evaporating into the air. And yet, at the right moment, the right droplet will meet the right ray of light, and the story will begin. And perhaps that's what makes rainbows feel so rare, but it's not that the colors aren't there, but that so many small alignments must quietly agree before they show themselves. The sun peeking through the clouds. The first sliver of sunlight after rain is almost a relief. It warms the skin, turns the wet leaves to silver, and makes the pavement glisten as though it's holding on to the day for just a little longer. The sun does not rush back into the sky. It steps carefully, peeking between clouds like someone looking into a quiet room. Light in these moments feels different. Softer, yes, but also more golden, more deliberate. It's passing through a sky still heavy with moisture, scattering in subtle ways before it even reaches your eyes. And somewhere between those beams and the lingering drops in the air, the conditions for a rainbow quietly lock into place. The clouds themselves play their part. Too many, and they'll hide the sun entirely. Too few, and the rain passes too quickly. But in the perfect balance, they frame the light just enough for it to arrive at the right angle. The precise tilt that allows each droplet to split it into colors. The sun does not aim at you. It simply shines as it always has, but you are standing in the one position where its light, the raindrops, and the earth's curve align in your favor. Move a little, and the picture changes. Stay where you are, and the bow will build itself before you. And that's the wonder of it. The sun has been shining all along, yet only now does it reveal this secret, bending light into something your eyes can follow like a painting unfolding in mid-air. Light that seems ordinary. White light looks simple. It's what we walk in every day without a second thought. It bounces off buildings, slides over fields, pours through windows. Yet this ordinary light is anything but plain. It's a perfect blend of every visible color, bound together so tightly that they appear as one. It's like hearing an orchestra playing a single note. You can't hear the individual instruments unless you listen in a special way. A rainbow is that special way for light, a moment when the parts reveal themselves without breaking the harmony. In the stillness after rain, when sunlight slips through the lingering droplets, this ordinary light begins to fracture into its true form. Each wavelength bends slightly differently, spreading apart into the soft fan of colors we know so well. And yet every time you see it, it feels new. Maybe that's because deep down you sense that it's not just light you're looking at, but a reminder that beauty often hides in plain sight, waiting for the right moment to be seen. The world is full of ordinary things that are not ordinary at all. Invisible colors. Inside every ray, it's strange to think that every beam of sunlight carries a secret. Inside what looks like a single, plain ray, there's an entire spectrum. Reds as deep as embers, blues as soft as twilight, yellows as warm as autumn leaves. They're all there, layered together so perfectly that your eyes read them as one thing. But they've been traveling side by side for millions of kilometers, from the heart of the sun to this very moment. Each color is a different kind of wave, some longer, stretching out lazily like a slow river, others shorter, flickering with a restless energy. They move together, yet their shapes and speeds aren't quite the same. And when the world finds the right way to slow them down or bend them, they begin to slip apart. The raindrop is that perfect slowing place. When light enters, the denser water bends the path slightly. But not all colors bend the same way. Red curves gently, violet sharply, and the rest fall into their places between. Inside that single moment of bending, the rainbow is already being written. Most of the time, this untying of colors happens invisibly, on glass edges, in soap bubbles, in thin films on water. But here, in the open sky, the scale is so large and the alignment so exact that the hidden colors step out into the air itself. And so, a ray you thought was ordinary reveals itself as a chorus of colors, each stepping forward with its own voice, yet still singing the same song. A journey that begins in silence. Light doesn't make a sound. It has no footsteps to announce its arrival, no rustle to tell you it's moving. It travels through space without a single whisper, carrying heat and color in perfect stillness. This journey from the sun to the earth takes just over 8 minutes. A rush in cosmic terms, but silent enough to go unnoticed until it touches you. By the time it reaches the raindrops, that light has already crossed unimaginable distances, past planets, through the trembling skin of Earth's atmosphere, weaving between clouds, and yet the part of its story you'll see in a rainbow is only the final act, the gentle landing after a long, silent flight. In a way, a rainbow is not just a picture in the sky. It's a record of light's patience. It has traveled so far and for so long, only to arrive here and split into colors for a few short minutes before fading back into the ordinary. If you stand very still, you can almost sense that silence. The kind that comes when you watch something happening in slow motion, even though you know it's all moving too fast to follow. That silence is where the magic feels strongest. And in that quiet, the journey continues, bending, scattering, finding its shape without ever breaking the piece it arrived in. Light meeting water. When light meets water, it doesn't just bounce off. It enters, it slows, it bends. This is the beginning of refraction into the gentle turning of a path without any visible force pulling at it. A sunbeam hitting a raindrop is like a traveler stepping into a new land where the rules of movement change without warning. The water's density is greater than the air's, so light has to adjust. It leans inward, bending as if to fit inside the droplet's curved surface. But each color feels this change differently, sliding into a slightly different angle. This is where the spectrum begins to stretch apart. Inside the drop, light is both guest and prisoner. It moves through, then bounces off the far side, then emerges again into the air. But when it comes out, it's no longer a single beam. It's a spread of colors, each escaping at its own unique angle. From where you stand, these many exits weave together into a single glowing arc. The process happens in every drop touched by sunlight, but your eyes only receive one precise ray from each droplet. That's why the rainbow you see is personal. No one else is catching the same set of rays you are. And so when light meets water, it doesn't just change direction, it changes identity, revealing the colors it had been holding all along. The gentle bend of a sunbeam. A sunbeam doesn't break when it bends. It simply shifts its path almost politely, as though it's been invited to curve. This bend, this refraction, is so slight inside the drop that it would seem insignificant if it weren't for what it does to the colors inside. Think of it like walking in a crowd where everyone's stride is a little different. Over a short distance, you stay together. But over time, the small differences add up and you find yourself spread out. That's what happens to colors inside the drop. A small bend at the start, a slightly different bend at the end, and suddenly they are no longer in the same place. Red light bends the least. It exits the droplet at a wider angle, giving it the outermost place in the rainbow. Violet bends the most, finding itself along the inner edge. Every other color finds its own resting place between those two. From the outside, this seems like pure chance. But inside the physics of light, it's as inevitable as the tide returning to shore. The bend is not chaotic, it's precise every time. And the more you understand this gentle bend, the more you realize how delicate the balance must be for a rainbow to appear at all. Why water turns light around. Water has a way of holding light for a moment, then sending it back. Not straight, but turned, as if it wants you to notice. Inside a raindrop, light doesn't just pass through. It reflects off the inner wall like a ball bouncing inside a glass sphere. This reflection is what sends the colors toward your eyes instead of letting them vanish into the ground. The shape of the droplet matters. Its roundness focuses the light into a narrow path. The angles of entry and exit must align so that when light leaves, it's directed exactly where you stand. A tiny change that you'd see nothing at all. It's almost as if the droplet chooses to show you only a slice of what it contains. Not the whole sphere of colors, but one bright strand, perfectly placed in your line of sight. Multiply that by countless drops and the full arc takes shape in the sky. Without this turning of light, this perfect inward reflection, there would be no rainbow. The colors would scatter in directions that never meet your eyes, and the secret would stay hidden. But when water turns light around in just the right way, the hidden spectrum steps into the open, and the sky begins to glow with the quiet geometry of color. The secret angles inside raindrops. Inside every raindrop, there's a map, not drawn on paper, but in the way light travels. When sunlight enters, it doesn't just move straight through, it bends, reflects, and bends again. Each step happens at an angle so precise it could be measured in fractions of a degree. And it's these hidden angles that decide where each color will emerge. Red leaves at one angle, violet at another, and all the other colors fan out in between. This arrangement is not random, it's a quiet law of nature, followed by every drop without exception. The beauty is that none of the drops know they're working together. Yet their perfect coordination paints the sky with a single, unbroken arc. You can't see these angles with the naked eye, but you can feel their presence in the way the rainbow always forms the same shape, always keeps its colors in the same order. Even in different parts of the world, even in different centuries, these angles remain unchanged. It's almost humbling. The thought that something so fleeting and delicate is governed by rules so steady. In the chaos of weather, the rainbow's geometry remains constant. And once you know this, every time you see a rainbow, you're also seeing the invisible mathematics that make it possible. The split of a single ray, what we think of as one beam of sunlight, is actually a bundle, hundreds of different wavelengths traveling together. But when that beam enters a raindrop, its unity dissolves, the light slows, bends, and, like a prism, the droplet spreads its parts apart. This splitting happens so fast you'd never notice it unless you froze time. Yet in that instant, the colors that have been hidden together for their entire journey from the sun finally travel on their own paths. Red drifts one way, violet another, and each begins a separate life, though all began as one. The process is so precise that even the slightest difference in wavelength determines how far apart the colors will appear. It's like watching a crowd of people leave the same doorway, each choosing a different street, yet all arriving where they were meant to be. And this is why no rainbow's colors ever blend into a single muddy smear. They've been separated by nature's own perfect sorting system. The drop does the work without knowing, and the sky becomes the canvas. It's in this silent split that the rainbow's story truly begins, not as a smear of light, but as a carefully layered band of colors. The unseen rainbow, within white light. Long before a rainbow appears in the sky, it already exists. Hidden in every beam of white light, you carry it with you wherever the sun follows, though you can't see it until the right conditions reveal it. This means that, in a way, a rainbow is not something the storm creates. It's something the storm uncovers. White light is not empty or colorless. It's full, so full that the colors overlap perfectly, masking one another. Your eyes combine them into a single tone, like hearing many voices speak at once, but only recognizing the chorus, not the individuals. The raindrop acts like a translator, pulling each color aside and letting it speak in its own voice. That's when you finally see what was always there, carried invisibly through space and time. It's a reminder that the world often holds more than we can perceive in the moment. Beauty can live unnoticed in plain sight, waiting for the right angle, the right medium, to show itself. The rainbow's sudden appearance isn't a creation, it's a reveal. And when you know this, even sunlight on an ordinary day feels richer, because you're aware of the hidden spectrum riding within it. Colors spreading like soft wings. When the colors finally emerge from the droplet, they don't explode outward. They open, slowly, delicately, like the wings of a butterfly testing the air after unfolding. Each shade, red, orange, yellow, green, blue, indigo, violet, fans out in a quiet order, holding its place without crowding the others. And perhaps that's why the rainbow never feels like a disappointment, even when you fail to reach it. Why the rainbow moves with you. Stand still and the rainbow feels fixed in place. Move even a few steps and it shifts. This isn't your imagination. It's the natural result of how it's formed. The droplets sending you each beam of color are always at a precise angle to your eyes. When you move, the set of droplets that meet that angle changes entirely. It's like a spotlight that follows you, except the light isn't chasing you. You're simply stepping into a new alignment every moment. The rainbow is reborn in each position, as if it's quietly keeping you company. This movement is subtle but constant. If you've ever seen a rainbow while driving, you might notice it seems to follow the car. That's because the geometry is always being recalculated between you, the sun, and the rain. It means that no matter how far you travel, your rainbow will always stay the same distance from you. Not closer, not farther. It's yours for as long as the sun and rain agree to hold it together. The faint second bow above the first. Sometimes, if the rain is just right and the sunlight strong enough, another arc appears above the main rainbow, softer, paler, almost like an echo in the sky. This is the secondary rainbow, and it's formed by light that has taken a longer path inside the raindrops. Instead of reflecting once inside the droplet, the light reflects twice before emerging. That extra bounce changes its angle and sends it higher into the sky, forming a larger arc above the first. Because the light loses more energy in the second reflection, the colors are dimmer. The secondary bow looks more delicate, like it's fading even as you watch. It's a quiet reward for paying attention. Many people never notice the second bow unless they look closely, but once you see it, it feels like discovering a hidden chapter in a story you thought you knew. And it's in that second arc where the rainbow's rules shift in subtle but fascinating ways. How the colors reverse in the twin. Look closely at the secondary rainbow and you'll see something unusual. The colors are reversed. Red is on the inside edge, violet on the outside. It's a small change, but it feels like looking into a mirror that rearranges the world. This reversal happens because of that second reflection inside the raindrop. The extra bounce flips the order of the colors before they exit, so the sequence unfolds in the opposite direction from the main bow. It gives the second rainbow a different mood, softer in brightness, but somehow bolder in structure, as if it refuses to follow the same pattern as its brighter sibling. Seeing the two together, one bold and orderly, the other faint and reversed, is like watching two dancers move to the same music, but in different steps. It's nature's way of showing that even in perfect repetition, there can be variation. A reminder that beauty doesn't have to follow a single path to be complete. Dark space between the two bows. Between the main rainbow and its fainter twin, there's often a curious band of darker sky. This dim strip isn't a trick of the eyes, it's a real difference in brightness caused by the way light is scattered. Inside the main bow, the raindrops send more light toward you, so the sky appears brighter. Outside the secondary bow, less light is sent in your direction, making it fainter. But in the space between them, light is directed away almost entirely, creating a soft shadow in the air. This darker region makes both rainbows stand out more sharply, as if the sky has drawn a line to separate them. It's called Alexander's band, named after the ancient observer who first described it nearly 2,000 years ago. And yet, even with that history, it still feels like a small mystery hanging in the air. Standing under a double rainbow with that dark band between them, you can almost feel the space as something you could step into. A quiet gap between two halves of the same wonder. The name of Alexander's band. The term Alexander's band may sound poetic, but it's simply the name given by those who first studied it seriously. Alexander of Aphrodisias, a philosopher in the 3rd century, noticed that this darker strip always appeared between the two bows. He didn't have the science we have now. He couldn't explain the precise angles or the role of multiple reflections. But he saw the pattern, and in a world without modern optics, even noticing it was remarkable. Today we know the darkness is just the absence of light scattered toward us from that region, but when you hear the name, you might imagine it as an actual band in the sky, a belt holding the two rainbows apart. It's one of those details that most people never learn the name of, even if they've seen it many times. And somehow, knowing it has a name makes the rainbow feel even more human. As if people have been leaving notes in its margins for centuries. In that way, Alexander's band is more than just a gap in the light. It's a link between the science we know now and the wonder that's been with us all along. Fainter colors hidden beyond violet. At the inner edge of violet, the rainbow doesn't truly end. Our eyes simply stop being able to see what's there. Beyond that lies ultraviolet light, waves shorter and more energetic than violet, invisible to humans but still present in the spectrum. Some creatures, like bees and certain birds, can see these colors. To them, a rainbow might extend further, carrying patterns and shades we can't even imagine. For us, that edge feels like a boundary, but it's really just the limit of our own vision. It's humbling to realize that what we call the rainbow is only the part we're able to detect. The full story stretches beyond our senses, out into colors that exist without our seeing them. That hidden extension makes the visible rainbow feel almost like a translation, a version of something bigger tailored to our eyes, the realm of ultraviolet light. Beyond violet lies a region of light our eyes can't detect, ultraviolet. Its waves are shorter, more energetic, and invisible to us, though they're present in every beam of sunlight. To our skin, they're familiar enough. The warmth of the sun and even the sting of a sunburn come partly from them. In a rainbow, ultraviolet is always there, spilling past the violet edge in a range of colors we will never directly see. It's like the quiet continuation of a song that fades for us but plays on for others. This hidden realm reminds us that our view of the world is incomplete. What we call all the colors is really just a fraction of what light can do. For certain creatures, the rainbow is longer, richer, and filled with shades we can't name. And though we can't see it, ultraviolet still touches our lives. It's in the glow of certain flowers, in the patterns on bird feathers, in the invisible maps that nature leaves for those who know how to read them. In a way, every rainbow you've ever seen has been only part of the truth, a partial translation of something bigger, invisible heat in the infrared glow. On the opposite side of the spectrum beyond red lies infrared light. These waves are longer, slower, and carry warmth more than color. We can't see them, but we can feel them. The gentle heat of the sun on your face, the lingering warmth on the pavement after a bright day. In a rainbow, infrared stretches out past the red edge, unseen but still very much present. If we could see it, the bow might not end in red at all, but fade into deep, glowing shades, like embers cooling in the air. Some animals, like snakes and certain insects, can sense infrared. To them, the rainbow might be a mix of visible colors and a warm shimmer that tells an entirely different story. Infrared reminds us that sight is not the only way to know the world. We can't see it, but we experience it through touch, through the quiet comfort of heat on a cool day. And it's humbling to realize the rainbow doesn't just carry beauty for the eyes, but warmth for the skin as well. How our eyes choose what to see. Our eyes are tuned to a very specific range of light, what scientists call the visible spectrum. This range evolved not because it's all there is, but because it's the most useful for our survival. It's where sunlight is brightest, where colors stand out most sharply, where the world's details reveal themselves. The rainbow we see is shaped by this limitation. Red to violet is the band our eyes are built to read, but light stretches far beyond it. We're like listeners who can only hear certain notes in a song, never the full arrangement. Our brains also play a role, blending colors together into smooth gradients, sharpening edges, and sometimes even filling in gaps. What we see is as much a creation of the mind as it is a reflection of the world. So the rainbow is both a natural event and a personal experience. Two people with different eyesight, say a child and an elder, may see slightly different rainbows even if they're looking at the same sky. It's a reminder that beauty isn't just in what's out there, it's also in how we're built to receive it, the limits of human color. There's a quiet truth about our vision. We are colorblind to most of the light around us. We see millions of shades, yet they're only a small portion of what exists. Ultraviolet, infrared, and countless other wavelengths move through the world without ever touching our sight. Even within our range, some colors we can't name exactly. We see them as blends, as gradients, never as pure tones, and some shades, like the precise blue of certain flowers or the green in deep ocean water, seem to live on the edge of what we can fully grasp. This limit doesn't make the rainbow less beautiful. If anything, it makes it more precious, because it means the arc we see is tailored to us, designed for the eyes we have. And in a way, our inability to see it all leaves room for wonder. There's comfort in knowing that no matter how many rainbows you see, there will always be more to them than you can know. It's like reading the first chapters of a story that continues forever beyond the page. Animals that see a different rainbow. For some creatures, the rainbow is a completely different sight. Bees, for example, can see ultraviolet patterns, which means they witness colors at the violet end that are invisible to us. To them, a rainbow might have an extra glow, a hidden band we can't even imagine. Birds often have 4 types of color receptors in their eyes, one more than humans. This allows them to see a richer spectrum with hues that blend in ways we've never experienced. A rainbow in a bird's eyes could be more vivid, more layered, more alive. Other animals, like certain butterflies, can detect both ultraviolet and polarized light, turning a rainbow into something entirely alien from our point of view. It's a humbling thought. The rainbow you see is not the rainbow the world truly holds. Every species carries its own version, shaped by its eyes and its needs. Bees and their ultraviolet patterns. To a bee, a rainbow doesn't end at violet, it keeps going. Bees can see ultraviolet light, so at the edge where our rainbow fades, theirs blooms with patterns we'll never see. To them, it's not just an extra band of color, it's a whole new language of light. This ability is the same one they use to find flowers. Many blossoms have ultraviolet markings, like landing strips guiding bees to the nectar. In a rainbow, the same wavelengths would stand out to them, glowing with cues we can't detect. It's strange to think that when a bee flies through a field after rain, it may be weaving through a rainbow entirely different from ours, the same light, the same droplets, but a world painted with colors we can't imagine. And that thought alone makes the rainbow feel bigger, not just in size, but in possibility. Birds with 4 color cones. While humans have 3 types of color receptors in the eye, many birds have 4. This extra cone lets them see into the ultraviolet range and blend colors in ways we can't begin to replicate. For them, a rainbow isn't just richer, it's more complex. Imagine a 4th primary color added to our world, creating combinations we've never named. A bird's rainbow might shimmer with hues that shift in ways ours never do, with subtleties between each band that we can't even visualize. This extra sensitivity also makes the world sharper for them. The faint edges of our rainbow might be clearer, the gradients smoother, the divisions more distinct. It's a reminder that the rainbow is not a fixed picture, but a personal translation. Every eye builds its own version from the light available. And in the case of birds, that version is something we can only envy from the ground. What a rainbow looks like to them. We can't truly imagine the rainbow as birds or bees see it. Even with technology, any attempt to simulate their vision is still just our 3-color eyes guessing. The truth is, their rainbow might not just be more colorful, it might feel entirely different. It could have shimmering effects we can't register, glowing edges that shift with each flap of a wing, or patterns in the bands that are invisible to us. Where we see a smooth sweep of red to violet, they might see intricate textures or even subtle breaks in the spectrum. This difference reminds us of something profound. We don't see the rainbow as it is, only as we are built to see it. Its true form is not bound to human perception at all, and maybe that's part of the magic, knowing the rainbow exists in infinite versions, each one shaped by the eyes that behold it. Why rainbows appear in mist and spray. You don't need a storm to find a rainbow. Anytime sunlight meets a fine mist of water in the air, the same bending, reflecting, and splitting of light can happen. That's why you might see a rainbow in the spray of a garden hose, in the mist near a waterfall, or even in the fine droplets thrown up by ocean waves. These small-scale rainbows can feel even more personal. You can walk around them, change their size, even make them vanish with a step. In these moments, you're not just watching a rainbow, you're creating one. The same geometry rules apply. Each droplet acts like a tiny prism, sending you only one angle of one color. The difference is that here, you can control the arrangement, turning the arc as you shift the spray or your position in the sunlight. It's like holding a fragment of the sky in your hands. And for a moment, you're part of the making. The miniature arc in a garden hose. One of the simplest ways to make a rainbow is to stand in sunlight and spray a fine mist from a garden hose. Angle it just right, and a tiny bow will appear, bright and close enough to feel like you could step through it. What's happening is exactly the same as in the sky after rain. The droplets from the spray are bending and splitting the sunlight. The difference is scale and control. You decide the density of the droplets, the angle of the sun, and your own position. These small rainbows can sometimes be more vivid than sky rainbows because the droplets are uniform and fresh and the light is direct. You can see the gradients more clearly, the reds warmer, the violets sharper, and when you turn the water off, the rainbow is gone instantly, and proof of how fleeting all rainbows are, no matter their size. Rainbows in the wings of butterflies. Some butterfly wings shimmer with colors that seem almost unreal. Blues that shift with each movement. Greens that flash and vanish as the insect tilts in the light. These aren't pigments in the traditional sense. They're structures that bend and scatter light in precise ways, much like raindrops do. When sunlight strikes the microscopic scales on a butterfly's wing, the structure splits the light into colors. But instead of forming a bow in the sky, it paints the colors right into your line of sight, changing with every angle. This is called structural coloration, and it's nature's way of using light itself as a paintbrush. It's the same principle as a rainbow, only smaller, denser, and more delicate. If you've ever leaned closer to a butterfly and watched its colors shimmer, you've seen a rainbow's trick performed on the scale of a single wing beat. It's a reminder that the rainbow's art isn't limited to the sky, and it hides anywhere light finds a surface willing to play. Light split by crystals and ice. Crystals and ice can act like nature's own prisms, bending light into colors the same way raindrops do. When sunlight passes through these structures, it can split into a spectrum, sometimes scattering into arcs, spots, or even full halos. In cold climates, tiny ice crystals floating in the air can produce shimmering circles or arcs of color around the sun. These aren't rainbows in the traditional sense, but they're built from the same basic physics, refraction and reflection. The angles are different, the shapes more varied, but the feeling is the same. Light stepping out of its usual disguise to show its many colors. When you see one of these displays, it feels almost alien, like the rainbow has left its familiar arc and taken on a new form. And yet it's still the same old sunlight, just finding another way to surprise you. The halo around the sun in winter On certain cold, bright days, the sun is ringed by a pale halo, a perfect circle that looks almost like a ghost of a rainbow. This happens when sunlight passes through high, thin clouds made of ice crystals. The crystals bend the light at a fixed angle, creating a ring that's usually white, but sometimes tinged with faint reds and blues. Unlike a storm rainbow, it doesn't depend on rain, just the silent drift of ice far above your head. Standing under a winter halo feels different from seeing a summer rainbow. The colors are subtle, the light colder, but the geometry is just as precise. It's as if the rainbow has dressed for a different season, trading bold arcs for a delicate crown. And in that pale circle, the same truth hides. Light never really loses its colors, it only waits for the right invitation to show them the rare fire. Rainbow in summer skies. Despite the name, a fire rainbow isn't fire at all. It's light passing through ice crystals high in the atmosphere. When the sun is high in the sky and the ice plates align just right, the result is a brilliant band of colors that runs parallel to the horizon. Unlike a normal rainbow's arc, the fire rainbow spreads wide and flat, as though the sky has been brushed with iridescent flames. The colors can be intense. Reds and blues so vivid they almost look painted. It's a rare sight because the conditions have to align perfectly. Most people go their whole lives without seeing one in person, and when you do, it feels almost unreal, as though the rainbow has decided to abandon its usual shape just to see if you'd notice. It's proof that the rainbow isn't bound to one form. It can reinvent itself when the sky allows. Moonbows in the quiet of night. A moonbow is the rainbow's nighttime twin, a bow formed by moonlight instead of sunlight. It appears when the moon is bright, the night is clear, and rain or mist hangs in the air. But because moonlight is so faint, the colors are usually soft, sometimes almost white. To the human eye, a moonbow can look ghostly, a pale arc that seems carved out of shadow. Cameras, with their longer exposure, can capture its true colors, revealing the full spectrum hidden in that dim light. Seeing one feels different from seeing a daytime rainbow. It's quieter, more secret, as though the sky is offering a gift it doesn't give to just anyone. You might stand there in the stillness, knowing that this is the same phenomenon you've seen 100 times, and yet it feels entirely new. Why, they are pale and gentle. Moonbows are made of the same physics as any rainbow. Light bending and splitting inside countless droplets. But the moon simply doesn't shine as brightly as the sun. Moonlight is just reflected sunlight, and it carries far less energy by the time it reaches us. Our eyes struggle in low light, so instead of rich reds and deep blues, we often see only a soft, silvery arc. The colors are still there, hidden, waiting. But our night vision leans towards shades of gray. A long camera exposure will catch them, but to us, the bow feels almost ghost-like. There's a tenderness in that faintness. A moonbow doesn't overwhelm you with color, it invites you in with restraint. You have to pause, let your eyes adjust, allow the scene to soak into you. It's as if the rainbow in moonlight has decided to whisper instead of sing. And in that whisper, it somehow becomes even more magical. You walk away remembering not just what you saw, but the feeling of being trusted with something rare. Stories, cultures, tell about rainbows. Across history, rainbows have carried meanings far beyond their science. In some cultures, they've been seen as bridges between worlds, paths for spirits, gods, or heroes to travel. In others, they're signs of hope, peace, or renewal after hardship. Norse mythology speaks of Bifrost, a rainbow bridge connecting Earth to the realm of the gods. In Hawaiian tradition, rainbows can be seen as the pathway for ancestors visiting the living. In parts of Africa, they've been linked to serpents or spirits guarding the waters. Even without knowing the physics, people understood the rainbow's uniqueness, indeed, its sudden arrival, its fleeting nature, its connection to both rain and sun. It felt too perfect to be an accident. And perhaps that's why, even now, a rainbow can still make people stop mid-conversation, point upward, and fall quiet for a moment. The science explains it, but the feeling comes from somewhere older. The rainbow as a bridge in myth. The idea of the rainbow as a bridge appears again and again. A perfect arc reaching from one horizon to the other feels like a road suspended in the air, a path that could lead anywhere. For some, it connects the human world to the divine. For others, it links the present to the afterlife or the living to their ancestors. In each telling, the rainbow is more than light. It's a connection between realms. It's easy to see why. The curve seems to rest on the earth, yet it's untouchable. It invites you forward but moves away as you approach. In that way, it feels both real and beyond reach, the perfect symbol for the space between worlds. Even knowing it's made of sunlight and water doesn't erase that feeling. Sometimes, the truth of a thing doesn't cancel the story. It deepens it. And so in our minds, the rainbow remains a road we can't walk, a bridge we can only dream of crossing. Science meeting, legend in the sky. Science and myth have always shared the rainbow. The myth gives it meaning, the science explains its making, and neither fully replaces the other. You can understand refraction, dispersion, and reflection and still feel wonder when you see the arc appear. The beauty of the rainbow is that it doesn't force you to choose. You can hold the legend in one hand and the physics in the other. You can know the droplets are bending light at a precise angle and still imagine it as a bridge, a promise, or a sign. In that sense, the rainbow might be one of the few things that unites our logical and poetic selves. It's proof that understanding doesn't have to take the magic away. Instead, the magic grows when you know how fragile the alignment is and how much has to go right for it to appear at all. And maybe that's why the rainbow has never lost its place in both science books and storybooks. Why rainbows still feel magical.
Rainbows appear without warning. You can't schedule them, you can't hold them, you can't keep them from fading. That unpredictability is part of their magic. They belong to the moment, and when that moment passes, they're gone. The sight of one stops people in their tracks. Not because they've never seen it before, but because it feels personal every time. You know it will vanish, and that makes it more precious. It's a beauty you can't own, only witness. Even now, with all we know, the rainbow still has the power to pull us out of ourselves for a few seconds. It's a reminder that the world can surprise us, even in familiar skies. And perhaps that's the greatest magic. Not that the rainbow appears, but that it still makes us look up. The short life of every arc.
A rainbow never stays long. Even under perfect conditions, it's a brief visitor. The sun moves, the rain shifts, the droplets fall or evaporate. The delicate alignment that creates the arc begins to unravel almost as soon as it forms. You can watch it change in real time. Colors growing fainter, edges losing their sharpness, the curve thinning as though it's being erased from the air. It's not sudden, but it's steady, and you can feel the inevitability in it. The shortness of its life is part of why it feels so precious. You know, even as you look, that you're seeing something that won't exist in a few minutes. And yet that impermanence isn't sad. It's the kind of fleeting beauty that feels right. Here for just long enough to be remembered. The rainbow's life is short, but in that shortness it leaves something behind that lasts much longer. how the sun and rain decide its fate. The rainbow exists only because the sun and rain are in perfect conversation. The sun sends light, the rain bends and returns it. If either one changes its tone, if the sun dips behind a cloud, if the rain moves on, the conversation ends. Sometimes you can see this happening. A patch of the bow will fade while the rest stays strong, or one end will vanish into thin air while the other lingers stubbornly. It's like watching the sky edit its own work. The angle of the sun plays a big role. As it rises higher, the rainbow drops lower. When the sun is too high, the geometry no longer works and the arc disappears altogether. The rain may still be falling, but without the right light, it stays invisible. It's a reminder that even the most beautiful things rely on balance. Too much of one, too little of the other, and the magic slips away. And in that balance, the rainbow teaches us that beauty is as much about timing as it is about form. The moment it fades back to white, the fading of a rainbow isn't a dramatic collapse. It's more like a slow breath out. The colors begin to dull, the edges blur, and what was once a vivid arc dissolves back into ordinary daylight. It's as though the spectrum is folding itself away, color by color. The light doesn't disappear. It's still there, still traveling through the air, still striking the raindrops, but without the perfect angles, it no longer separates into its colors for you. It blends back into the whiteness of sunlight, invisible once more. If you're watching closely, you can almost feel the exact moment when your eyes stop reading the colors. It's subtle. A shift so gentle you might miss it if you blink. In that moment, the rainbow isn't gone, it's simply returned to hiding inside the light. And somehow, knowing that makes its disappearance feel less like a loss and more like a retreat. The colors that linger in memory. Long after the rainbow fades, the image stays with you, not as exact wavelengths of light, but as something softer, more personal. You remember where you were standing, the scent of the air, the way the world felt for those few minutes. The memory of the colors is less about precision and more about the feeling they carried. You might recall the red as warmer than it was, the violet as deeper, the green as more alive. Your mind edits the scene, making it yours. And when you think of it later, you might feel a small lift, as though part of that light is still with you. That's the quiet gift of the rainbow. It leaves more in you than it takes from the sky. The colors don't just fade, they settle into your memory, ready to glow again whenever you call them back. And sometimes remembering is almost as good as seeing. The sky waiting for the next one. Once the rainbow is gone, the sky feels different. Cleaner, calmer, as though it's reset itself. The rain dries, the sun climbs higher, and the air begins to move on. But somewhere in that blue, the conditions for another rainbow are already sleeping. You won't know when it will return. It might be tomorrow, or next season, or years from now. But the same laws of light and water will still be waiting, unchanged, ready to repeat their quiet miracle. That's the beauty of it. Rainbows are both rare and inevitable. Given enough time, the sun and rain will find each other again, and the sky will write that arc across itself once more.